Hi everyone. Okay, so we're up to geologic history and fossils. In your packet, it starts on page 42. Again, you get to skip the objectives and the key vocabulary. And we're going to start on page 43 with the essential knowledge and skills. Alright, so the first question says, give examples of ways in which fossils can be preserved. Those answers include molds, casts, original bone material, or shells. Nearly all fossils are found in what types of rocks? There are three types of rocks: igneous, sedimentary, and metamorphic, and the correct answer there is sedimentary. Sedimentary rocks form under the ocean, and that's where a lot of organisms live, so it makes it easier for them to be incorporated into the rock. Number 3, in Virginia, fossils are found in the following provinces. Okay, so we've briefly gone over the physiographic provinces of Virginia from west to east. This includes the Appalachian Plateau, the Valley and Ridge, the Blue Ridge, the Piedmont, and the Coastal Plain. Of those, only 3 have sedimentary rocks in them. That includes the Coastal Plain, the Valley Ridge, and the Appalachian Plateau. The Blue Ridge and the Piedmont are mostly igneous and metamorphic rocks. They form from either volcanoes or deep under the surface of the earth from high pressures, temperatures, and do not have fossils. Number 4, most Virginia fossils are blank organisms, which indicate the state has been covered by what? The answer is marine organisms covered by seawater. Number 5, over geologic time, life has become more complicated. We said in the fossils unit that you start with simple single-cell bacteria, and by the time you're in the Cenozoic, you've got complicated mammals like, for example, elephants and giraffes. Number 6, Earth is very old. According to scientific estimates, we think the Earth is 4.6 billion years ago, or formed then. Number 7, relative geologic time places events into a sequence. Number 8, fossils, superposition, and cross-cutting relationships are used to determine the relative ages of rocks. Talked about these. We said superposition establishes the oldest rocks are on the bottom unless they're disturbed. Cross-cutting relationships would be things like a fold or a fault that cuts through pre-existing rocks. Number 9, absolute time places a numerical age on an event. Number 10, blank, that would be radiometric decay is used to determine the absolute age of rocks. Carbon-14 is probably one of our most common elements that we use to do radiometric dating. Alright, please skip to page 44. If I'm going too fast, feel free to stop the video or rewind it. You guys know how to use YouTube videos, I'm sure. Alright, on page 44, question number 1 says, what is the approximate amount, the element that remains after 3 half-lives? If you go to 3 on the x-axis, go up to the curve and go across, the answer is 12.5%, which is answer C. The second question asks, which of these formed in the last of the sequence? The answer should be B. I'm sorry that got cut off. The reason is that you notice the layers are folded. So C would have come first, then A, and then the fold would have produced in D, and then there would have been more displacement along the fault causing B. Number 3, which statement correctly describes an age relationship in the geologic cross-section below? So we've got to look at the diagram and consider our answers. Is the sandstone is going to be younger than the basalt? And the answer is no, the sandstone is cut by the basalt, so salt has to come later. 2, the shale is younger than the basalt. Yeah, there's your correct answer. Shale lies on top of the basalt, and therefore it has to be younger. If you go to the next question, it says, according to the graph above, a piece of timber containing 1/8 the amount of C14. Well, you've got 1/8, you go on the x-axis, go up to the curve, and the answer is C, 17,100. The next question is a little tricky. They give you a chart, and it says, what is the amount of the original C14 remaining after 34,200 years? All right, so here's what you got to do. Fill in the chart. Going down the second column, you have to keep dividing the fraction in half. So they've already done 1, 1/2, 1/4, and 1/8. There'll be a 16th, a 32nd, and a 64th. Then the last column, you keep adding 5,700 to the numbers, work your way down. And what you'll find when you fill in the chart, that at 34,200 years, there would be 1/64th of a gram left. For number 6, the most recently formed rock unit is at location D. That's because the intrusion cuts through everything else, all the layers and the fault. Number 7, which graph best represents the radioactive decay of uranium into lead? Well, if we look at our 4 graphs, the one that makes the most sense is number 1. Okay, uranium, number of half-lives is representing the time. So as you go across the x-axis, you're going through more time from the oldest to the youngest. Uranium is progressively decreasing and turning into the lead. And we've hit the answer. We've hit the